Okay, I'm Lester Knutson, and we're going to talk about Informix partitioning and automatic partitioning, which is one of the new features that have come out in the last several years. And I want to joke about this. I said this is really going to be about best practices for Informix partitioning. I misspelled it on a couple of posts and put PEST, P-E-S-T practices. And I know best practices are sometimes a pest, but I didn't really mean it that way. I apologize for that. Anyway, I'm Lester Knutson. I've been working with Informix since 1983 and done a lot of these webcasts and looking forward to doing another one. The webcast is being recorded and the slides will probably be available next week. Also, the scripts I'm going to use, and I sort of built this with a set of scripts so you could download the scripts and do it yourself. All you need is a stores database for a source of data. Please make sure your phones are on mute, as background noise can distract everyone and get in. If you have a question, use the chat button, which looks like this. It's in the upper right corner, and I'm hearing some background noise. But when I'm full screen like I am right now, I don't see the chat, so it may take a minute or so to respond. I'll go through the chat at the end of the presentation. So put your questions in as you think of them, and we'll go over them at the end. So this is what I want to cover. It's a brief overview of Informix partitioning, PDQ and partitioning, and then I want to talk about the automatic Informix interval partitioning, which is a really great way to manage huge amounts of data. I want to talk about the impact that has on SQL explain plans and what to look for there. Then I want to talk about rolling windows. And a rolling window is when you limit the number of partitions you have. Let's say you want 4 years of data. And after 4 years, you want the oldest data to drop off. That's called a rolling window. And Informix has a way of automatically dropping off the oldest data. And we're going to take a look behind the scenes sort of at how they detach or drop a partition. And then I'm going to give you an option if you don't want to do the automatic and you want control over it, how to do it manually. So first key point here is fragmentation equal partitioning. In the old days, we used to call this Informix fragmentation. In fact, you still do. They mean the same thing. Almost everywhere in the syntax you use the word fragment, you can now use the word partition. I like to use the word partition because that, I think, has a clearer explanation of what you're doing. You're partitioning your data into different sets of data in separate table spaces. Fragmentation can also mean extents, and this is what I call the bad fragmentation, when you have too many extents, and that slows down access to your data. Now, the benefits of partitioning is you can get faster database queries because Informix can read each partition at the same time. So let's say you have 5 terabytes of data, and to do a sequential scan of that takes 5 minutes. If you partition that into 5 partitions of 1 terabyte each, you can read all 5 at the same time in 1 minute, and you've just made your query 5 times faster. Secondly is when you partition data by expression or by interval, Informix can eliminate certain partitions. And let's say you're just looking for 1 year's worth of data, not all 5 years. Informix can go to the partition that has that 1 year and just read that. so there's a lot less data to read. With very large tables, it removes the limit on the number of pages you have, and basically partitioning allows you to have tables of infinite size. And lastly is it eases table administration, purging data. You can automate that. We had one client we're working with, very large database, used to run a purge process that would take 6 hours. With the automatic rolling windows, that 6-hour job went away because it happens automatically. But the bottom line is speed. Partitioning gives you more speed and a faster way to access your database. Now, you want to partition large tables. My sort of baseline is if it's under 2 gigs, it's probably not going to be worth partitioning it, even though you can. But when you have any table greater than 2 gigs, it will really benefit from partitioning. Any table that's bigger than a chunk will benefit from partitioning. And any table with more than 16 million pages will benefit from partitioning. And then large tables, because you partition the data, you don't have to read the whole table. That can benefit. You can also partition indexes, and the same thing happens for large indexes. Now, the key thing with large tables is there is a hard limit of 16 million pages that a table can hold. And if you have a table hitting that limit, you either have to purge data or do something else. One way to alleviate that problem is to partition that data. And once you start partitioning that table, you can have multiple partitions of 16 million pages. Now, parallel database access is one of the key reasons for partitioning, because you can read all the partitions at the same time if you need to do a sequential scan on the whole table, or you can read just one partition and fine-tune it down to that one partition. I've worked with a number of organizations that would partition by year and month, and almost every query has a year and month or a date range in it, and that allows you to fine-tune your queries automatically. You actually don't have to do anything. The optimizer does this behind the scenes, and it goes out and reads just the partition, just the piece of disk that you need. You can also partition data into different classes of table, like historical rows. You can put on slower, cheaper disk in a partition for slower, cheaper disk. And your current rows you can put on your fastest SSD drive. That's another really good advantage of partitioning. Now, you don't need to have a partition in a separate DB space. Back when fragmentation first started in version 7, you could only fragment by DB space. For the current scheme, and this is why I like the word partition better than fragment, you divide a table up into partitions. It's one table, but each partition has its own table space for data. And so you can take a table and divide it into 12 partitions and 4 DB spaces. And most of the examples I'm going to use today do something like that. We have 4 DB spaces we're going to be working with, and we're going to partition a table multiple ways in those 4 DB spaces. Each partition is a separate table space and can be read separately. And all 12 partitions could be read at the same time if your disk can handle the I/O on that. Now, there are 4 types of partitioning. There are a couple of others, but I'm not going. I want to focus on these 4. Round robin is the simplest. partition by expression and partition by list are two of the old favorites. And then interval partitioning or automatic partitioning. I wish they'd use the word automatic partitioning, because that's the newest that I want to talk about. Round robin is simple. It's very fast for inserts. What it does is you tell it how many DB spaces, and it takes your table and divides it up among those DB spaces. The first row goes in the first DB space, the second row goes in the next DB space, the third row goes in the next DB space. And it goes round robin like that. So if you have 4 DB spaces in a load, you can be loading into all 4 partitions almost simultaneously at the same time. So this is going to be the fastest 4 loads. There is no partition elimination. There is nothing in your query that can say only look at this partition. So if you do any query, it has to look at all 4 partitions. And so it's not going to help your speed of queries. Also, dropping or adding a partition will require rewriting the whole table. And so that can be a problem. In fact, there's a little bit of overhead with that. And lastly, round robin only works for tables. It doesn't work for indexes. And I'm going to talk about indexes later because they're a whole separate problem with partitioning. But when you partition something by round robin, you put the index someplace, and there's one index for how many partitions you have. Now, my old favorite was partition by expression. And this can be a very simple where clause that you partition the data. And it could be by year, by month, by week, by state, by anything. And you basically define your partitions with a where clause. And you can have a remainder partition that will hold any rows that don't meet that where clause. And what the optimizer does is every time you run a query, it looks at the table definition starting at the top and goes from the top to the bottom, evaluating it and saying, where do I insert the row or where do I read the row from? And because it's part of a where clause, if your query includes, let's say you partition by date, if your query includes that date, it only has to read the one partition with that date on it. It doesn't have to read your 20 or 30 or how many partitions you may have. Now, long list of expressions can be expensive, and the order of the list is very important because it starts at the top of the list and goes down. You always want the most used expression at the top of the list. So when you alter a table, you want to add the new partition at the top of the list because that's probably going to be the one that's most used. Now, partition by list is much like expression, but it creates a hash on a list. And this is very simple where you say partition and then in, and these values go here, in, these values go here, in, these values go here. And you can have a remainder space if you need to. This can be slightly faster than expression because I think partly because it's hashed internally, but also partly because it's very clear. A really good example of this is if I need to partition something by state, I might do it by list and take the 50 states and divide them into 10 partitions. And I've got several algorithms where I've done this, and create list, and then doing queries or inserting rows, it can go look at that list and say, okay, I only need to read this one partition because I'm dealing with California today. Or this query deals with Virginia, so I'll go read that partition. And so this is a good option. Now, the best practice for both expression and list is always locate your most used expression at the top of the list. When you add a new year, I always want to make sure you add it at the top of the list, not at the bottom of the list. Because if you add it at the bottom, it has to go through the whole list to go find that expression. And what it does is as soon as it finds the first valid expression, it goes there. I once had a client I was working with, they had an expression that started up with something like, where row between something and this number, put it in here. When the row is greater than this number, put it here in DB space 2. Where the row is greater than this number and this number, put it in DBA space 3. But what happened, because that second expression had just a greater than, it didn't have a less than, everything went in that second partition. So you've got to be very careful with your logic. Or clauses can really get you in trouble. Had one that I was helping someone debug, and they had a really nasty or clause. And I was like, why do you make it so complex? What you really need to do is figure out a very simple way of expressing your expressions. Nested expressions, where you have a bunch of things in parentheses, you can do them. You can do very sophisticated expressions. They just make it more complex. And when they make it complex, a couple of things can happen. You can get the wrong results, or and they're actually not the wrong results, because the computer's telling you what you told it to give you, but it may not be what you want. Or sometimes you can get errors, like you can think you have every base covered and you insert a row and it can't figure out where to put it. So keep your expressions simple. I like to keep them very much equals or between, and make sure you have no gaps in your betweens. Now let's talk about the new interval range partitioning, and this is what I call automatic partitioning. This can be a number field, a date field, or a date time field. And what you do is you give it a number, a date, or a date time, and then you tell it how many partitions to make, or you tell it what unit to use. Like one I use a lot is month. And that says create a partition automatically for every month. So you insert 12 months of data, you'll get 12 partitions. You insert another month, and automatically you get another partition. And the examples I'm going to use today will show you how that works. You can have a list of DB spaces to store the data in. You can have one DB space and have all the partitions in one DB space, but then you're not really taking advantage of the I/O ability. You can create a function to decide which DB space to store stuff in, a user-defined function if you really want to. And then you have a default partition, primarily to store older stuff that won't happen. So this is really a helpful utility, and we'll demo that in a couple of minutes here. But here's a quick example. I'm saying partition by range, and I'm using rec date. And it can partition by anything that it can convert to a number. So what it does here is it takes that and says, okay, the interval is going to be 1 month. And so it takes rec date and converts it to a month. And so every month I'll get a new partition. And I'm saying store it in these 4 DB spaces. I can have 30 partitions in those 4 DB spaces. I could add more DB spaces if I want to. And then you need a place for values prior to the first value. And this usually if you do it right, creates an empty partition that is never used. But you need a default kind of partition for whatever your earliest data is going to be. Now, rolling windows takes that concept and says, instead of having to purge data, maybe let's have Informix either drop or detach the partitions with that oldest data. And this just adds one line to the syntax I had before. And here I'm saying I'm going to have 12 fragments, and then after I've got 12 months, so I'll have 12 months, 12 partitions. Once I get the 13th month, detach it. You can also say drop there instead of detach. And it will drop or detach that earliest month. And then another month of data comes in, the oldest month gets detached. And that's what's cool about this. It always detaches the oldest data or date range. Now, there are some problems you can have here. I had a customer that was working with this in a test environment, and by accident, their testing application put in a ton of future dates, and suddenly all their current data was gone, and they had just this test data, which they were in a test environment. They proved that it works, but you've got to be careful with that, because if you want a year's worth of data and you accidentally let slip in some future data, you may lose some of a year's worth of data. Now, let me talk about PDQ and parallel database query just for a minute, because that plays into partitioning quite a bit. And I'm going to show you one little simple thing you can do to take advantage of PDQ and partitioning when we get to the examples. So PDQ takes any large query, scans, sorts, joins, and divides it into multiple threads or multiple tasks. And in order for it to work, you have to have more than one CPU VP. You need one or more temp DB space, and then the table you're reading needs to be partitioned or fragmented. And then Informix can divide the SQL. Let's say your table is partitioned into 12 partitions. Informix can then create 12 threads that read all 12 partitions at the same time. And voila, your data is going to be read 12 times faster than it was before. This is sort of the way PDQ works. Your SQL comes in. If PDQ is turned on, it gets divided among the CPUs, and they can all read the same disk, and they come back and give you the results much faster. Now, you enable it by the PDQ priority environment and variable. This can be in your profile, and it can be an SQL statement. I'm going to show you in an SQL statement. And what I like in a lot of cases, and I should warn you, this doesn't work well for OLTP statements. Don't turn it on for everybody. But for reports, for things that do complex queries, even just setting PDQ priority to 1 will turn on parallel reads. And that's what I like. That's what I want, is parallel reads. And set PDQ priority to 1 will turn that on. If you set it to 100, you potentially could lock other people out of the system, because you're saying, give me 100% of the resources, don't leave anything for anybody else. Not sharing very well there with your other users. PDQ priority 1 says, yep, I want to do parallel reads, and then leaves everything else for everybody else. Now, you can control it with some on-config settings with on mode. There are 4 parameters in the on-config file that control it. You can also change them on the fly with on mode. And you can use onstat -g MGM to see what parallel queries are running. What will happen? Let's say you have PDQ priority, the default max PDQ priority set to 100. You have 4 users running PDQ priority of 25. 5th user comes in, wants to run PDQ priority of 25. They'll wait until one of the 4 is finished, and because there are no more resources left. And that's why you do have to manage it. I like 1 because PDQ priority 1 needs almost no management. You can have 100 people running with that on. And the key thing is you don't want to do PDQ priority when you have OLTP query running. Now, partitioning tables will benefit without PDQ priority, and I'll show you that in a minute when we go through some set explain examples. But with PDQ priority turned on, you can get a little bit better performance. So the keys is your table must be partitioned for this to work. You've got to have multiple CPUs to take advantage of multiple threads, and you really need multiple temp spaces. Now, if all you want is parallel sorts, there are 2 parameters, psorts and psort dbtemp, that can be used. Psort nprox is the number of CPUs to run sort threads on, and psort dbtemp is the number of temp spaces to use for sorting. And if you have a RAM disk, this works really good. Here's an example where on an 8 CPU system, I'm saying, in addition to all the CPUs Informix is going to take, I'm going to use 8 for sorts, and that I have 8 temp spaces defined that are separate from DB. These are not DB spaces. These are file system spaces. That's why they can work really well on a RAM disk. On a 4 system, 4 CPU system, I might do something like this. So let's get into our examples and dive in here. And let me just make sure see if there are any chat questions before I jump in. I've lost the chat window. Okay, it doesn't look like there's anything in the chat yet. So what I'm going to do is go through a bunch of examples, and we'll start off with round robin partitioning. We'll take a look at the sysfragments table, and I want you to understand how you can read and see what Informix is doing internally in sysfragments with your fragments. We'll take a look at expression partitioning, and then we'll take a look at automatic partitioning. We'll take a look at index, the impact indexes have. We'll take a look at the impact of SQL, and we'll take a look at rolling windows and automatically dropping partitions and manually dropping partitions. So those are all the examples. I have a set of scripts here that I'm going to use to go through. And let me just get started here. The first script I've already run is a setup script. And all this does is it goes out and it's created 4 DB spaces on my server for this exercise. I created 20 gig DB spaces. For using the stores data, you don't have to create them that big. So if I do an onstat -d, you can see my 4 new DB spaces are these, which are DBS4, A, B, C, and D. And so everything I do is going to be in those 4 DB spaces. So let's start up DB access. Go into query language, not going to select a database because the first thing I'm going to do is just create a database called test partitions with log. And now I have my database. Let's create a base table. And what I'm going to do here is read from the orders table in the stores demo database. And I'm going to create 14 months of data. And I'm just going to insert all the data from the orders table 14 times with a different month. And that's all I'm doing here. It's not doing any partitioning, but this is going to give me the base data that I need. So that created 322 rows. As you can see, I have the partitions by 12 months for 2017 and 2 for 2018. And each partition has 23 rows. And at the bottom of the query, I query sysfragments and say, how many data partitions do I have? I have none. I do have one index partition. And this is the first little thing that is of interest. I'm going to run my show partition script. And I use this throughout. This reads sysfragments to show me what the partitions are. Now, a key thing you got to do is update stats before you run it, especially if you don't have an index, because otherwise it'll work. You just may not see the right stats. So this tells me I have one fragment out there for the index. Every time you create a detached index in the later versions of Informix, it creates a record in sysfragments. And I can tell that the fragment type is I. That means it's an index. It's for base orders table, and it's in the data DBS, which is the default database I created this in. And if I look at sysfragments, this is select star from sysfragments for that one row. It tells me it's an I. Gives me the name of the index that it's using, and it tells me how many pages it's used and how many rows are in that partition. So it gives me enough basic information about that index. And even if you haven't done any partitioning, you have records in there for indexes. Okay, so now let's get into some fun. Let's do a partition by round robin. And as you can see here, what I'm doing is I'm just creating a table called orders RR, which is partitioned by round robin in each of the 4 DB spaces. And then I'm going to insert into that select star from the base table. So I'll get 322 rows. Then I'm going to create a unique index on that table, and then I'm going to alter that unique index and make it a primary key. And here I go. It says, okay, here are the number of rows you have, and I have 322, year, month. I've got 4 data partitions. Remember, I put this in, let me just rerun it, and then 1 index partition. And that's because that's what I did. I said partition round robin in these 4 spaces. It randomly put them in there round robin. Now let's go out and look at the partition detail for this data. And what it says is I have 1 index fragment type and 4 fragment types for data. And here's my first fragment type. The expression is blank, and it's saying it goes into data for A DBS. The next one goes into data for B DBS. The next one goes into C and then into D. And then my index goes into data for DBS. And if I look at the details of that partition, the first one is the index, and it tells me I have 4 pages used and the number of rows there for that index. And the next one is for the table, and it's about 80 rows in this partition, 80 in this, 81 in this, and 81 in this partition. So that's the basic partitioning by round robin. Now, let's take a look at expression. And this is an example of what I used to do all the time. Here I'm taking a year and a quarter. And we used to have these elaborate scripts that every quarter would go out and add more partitions. So I'm saying partition by expression. And I'm giving each partition a name. Notice that because you'll see, this is very important, when you look at the names that the automatic partitions get created. I could give it any name I want here. And then I'm saying where order date between, and I'm giving it a range of dates. And if I had my dates wrong, I could potentially get a record that fails because it slipped through the cracks, like on leap year. So you've got to be very careful when you do this. And this is a good example of very bad partitioning because I have the current stuff at the end. What you want to do is put that at the top so that the most current stuff, the stuff you use, the partitions you're going to use the most, appear at the top of this list, not at the bottom of the list. And then down here, I'm going to insert my data. I'm going to create an index with a primary key, and I'm not partitioning the index, even though I could partition the index the exact same way. And then we'll take a look at the results. So there I have. And you notice number of data partitions is 16, and I have 1 index partition. And let's look at show partitions. So this is going to go through and look at each partition and show us what's out there. So again, it says I have 1 index partition, 16 data partitions, and you notice here in the expression field of sysfragments, I have the expression that I'm partitioning by. And that's what the optimizer is going to use every time I need to run a query or insert rows or delete a row. And then I have the index with no expression. It just goes into 1 dB space. Now let me jump back to the slides for a minute because I want to make sure I didn't. Oh, sysfragment table. I want to talk about that for a minute. So some of the key fields in it, fragment type is going to be T or I, T for a table, I for an index. Table ID is going to be the ID in sys tables, so you can join with your table sysfragments to sys tables to get the name. The index name is actually going to be the name of the index. And the part num is going to be the address on disk of that. And then strategy. Let's take a look here. We'll come to it in just a minute. Okay. This tells you how it's partitioning things. And I should have the word index in the DB space. R is round robin, E is expression, N is interval or rolling windows, L is list, and then you have table and hierarchies, which I'm not going to talk about now. They're a whole separate topic. And it tells you, along with that, there are a couple of byte fields, and they become important with some of the automatic stuff because they're used, but you can't read them because they're binary fields. And it tells you if update stats have been run. And again, you've got to run update stats, how many pages are used and how many rows are used. And this is a partition name. If you ever want to drop or detach a partition, that's the name you will need. And with manual partitions, you want to give it a name that you can then use and drop and detach it. Okay, so that's the sysfragments table. I've done round robin, I've done expression. Now let's do the automatic partition by range. So here I'm taking my same table, I'm calling it orders interval, and I'm going to partition on order date, and I tell it it's going to convert that to a month. And so for every month, I will get a partition. So as you saw earlier, we have 14 months of data. So when I run this, it should create 14 partitions. And it's going to round robin those 14 partitions in these DB spaces. So first partition goes in A, second one goes in B, next one goes in C, next one in D, and then it's back. And I'm telling it anything before this date is going to go into data DB space. It's sort of a safety catch for old data. I'm going to insert the data, create a index, and then we'll take a look at it. So let's run. But instead of 14 partitions, look at it. It created 18. And I'll show you why in a bit. They're overhead. And I have one index partition. So let's take a look at these partitions. I'm just going to run my little query here to show the partitions. So one index, 18 with the table. The first table one is overhead. It's got blank information here. It's all in the byte fields. The second one has an interval there in the text, but it's primarily overhead too. There are 4 overhead partitions when you do a partition by interval. And then I have another overhead entry here that tells me what, I should say 4 overhead partitions, 4 overhead rows in sysfragments. And then I've got one that has a list of DB spaces that I'm partitioning by, and then I actually get into the data. And look, it's converted my data into nice values. And it did that automatically. I don't have to manage, and that's why I like this. I don't have to manage the partitions itself. Now, let me figure out where I am for a minute. I've done the show partitions. I said there are 4 overhead partitions, and not partitions, 4 overhead rows in sysfragments. And 14 with table data. Now, let's add some more rows, and let's see what happens. So I have a query here called add more rows. And what it's going to do is it's going to go out and put in 2 more months of data. And there are no partitions out there for these 2 months. There is no May 2018 or June 2018 partition. And you notice I also skipped 2 months. What's there is January and February. So March and April aren't there. Let's run it. Now I have 20 partitions. I have a few more rows, 20 partitions, and still 1 index partition. So it's 16 partitions with data. The 4 I had plus 2 more. And there are 4 overhead. And one index partition. And so if I come out here and look at my show partition query, I've got my 20 there. Let's take a look at what's in those 20. And what you'll do is I go through these, you'll see that it added, so it goes from 2/1/2018 to 3/1/2018, and skips March and April, and I have May and June, just like I projected. So this is great. This is what automatic partitions do. And each of those is a separate partition. Just for the fun of it, let's go do an on check. And we're going to on check PE. Let's just on check the last DB space. And you can see here my my tables for the orders rolling window table. I have one partition there, because remember I did that at the DB space level. You can't do round robin by partition. For the orders by expression, I have 3 partitions, and for the orders by interval, I have 3 partitions here. And then for the rolling orders interval, I have another partition there. And you can see I've got my different rolling orders partitions. So those partitions are getting created. Now, let me see. So we did 4. I'm going to talk about indexes now. Let me just make sure I don't have any slides to do. Indexes. Good segue here. Indexes can be a problem with partitioning, because if the index, if you need to repartition or drop or detach data, indexes need to get rebuilt. And that can take a long time. In fact, that can be one of the big reasons folks don't like to drop or detach partitions, because of the amount of time it takes to rebuild indexes. Now, the best performance is to detach or drop your indexes by partitioning them with the same method as a table. And I'm going to show you that. It can be fairly simple to do that, and that will get you the best performance, because then when you detach the table, the index gets detached with it. But if you don't do that, when you detach or drop a partition, you got to rebuild the index. And to me, the fastest way to do it probably is to drop the index, detach your partition, and then rebuild the index. Now, so let's take a look at an example with an index. And what I'm going to do here is partition just like I did before. This is the same orders interval, so it's going to drop that orders interval table that we created earlier and recreate it. It's going to partition it the same way, and then I'm going to create an index, and I'm going to partition the index using the same method as the table. Now, I want, and this is the point I want to make here, the primary key on this table is order number. And I want that, but since that is not what we're partitioning the data from, it can't just create a partitioned index without the order date. So all you have to do is say order number, comma, and then add the field that you're partitioning by to the index, and it can then partition that index just like your data. And so this is a workaround. If you have 3 or 4 indexes, you can do that with 3 or 4 indexes. and put whatever field you're partitioning the table by in the index. It does make the index a little bit bigger, but it makes it much easier to maintain because then you can drop and detach it fairly quickly because the index is already partitioned the same way. Now, this will create more partitions for the indexes. So let's run it. So I have 18 data partitions. We have seen that earlier. And I have 19 index partitions. And there's one more overhead row in sys. It's not really partitions. It's rows and sys fragments. I apologize. I keep calling these partitions. And so let's go look at the show partitions for this. And there are my 19 index rows and my 18 table rows. And if I take a look at the table rows, you can see that they all look good. And then if I look at my index rows, I can see the overhead ones, and then I've got a expression value just like my other data. So here the server is automatically creating partitions on the table and the index. Now, I want to take a look for a minute now at SQExplain and how that affects all this. And so let me drop out of here just for a minute. Make sure I don't have an SQExplain file. I don't have one. And so let's pick. I've got 5 example queries here. The first query, and I want to point this out because I'm going to run it twice. The first time I have PDQ priority turned off. And so this first query is going to read all the partitions. And it's going to, so it's going to have to do a sequential scan on the whole table. And it's going to give me a year, month count. The second one is only going to read one partition, but maybe it won't, because notice how I've got the where clause. This third one is also maybe only going to read one partition, but notice the difference in my where clause here. And I want to point this out because this is the way you would think you need the where clause, because that's the way I created the partitions, but that's not. You really need the where clause like this, because that's the way it has interpreted those partitions. And then I'm going to read one record, and the point here is to show you what happens when you just say, give me one record, and the second query is going to get that same one record, but I'm adding in an order date. And we'll take a look at how the optimizer handles these two queries. This is sort of some hints for how you can write better queries with partitioning. So let's run this. I have a setExplain turned on, run it. I've got my one row. Okay, let's look at the SQExplain file. Okay, so the first query, the first thing I want you to look at is it does a sequential scan, which I was expecting, but it says serial here. Serial means it's going to read one partition at a time. Now, fragments all means it's going to read all partitions, but it's going to read them one at a time. And so if I have 20 partitions, it's going to read one, then the next, and the next, and the next. And here are my stats from that. Now, this, I want to look at the two counts. The second one is where I had a year and I converted it to a year and month converted to a month. it still says it's going to read all the partitions. It's serial, one at a time. It's going to read all of them. And then below that, put in a filter. So it's going to have to read every record. And the point here is how you write SQL is very important. Now, my third example, I have where order date between, and I give it 2 dates. And now look what it does. It's going to read it serially, but it's only going to read one partition. When you see a number here, that is the number of the fragment or partition that it's going to read. And it tells you right here, this is the one it's going to read. So just by putting the date, and this is why you want to look very carefully at sysfragments and how it stores your data, and converting your data in word clauses to something like that can benefit you and speed up things. And this is without PDQ. The second version of this query will be much faster. On a big table, if I had 1 billion rows in this table, it'll have to read every partition to find the 1 month I want. Now, same thing here. I'm saying, okay, let's look up order number 300. And it says, I can use an index to find order number 300, but I've got to look at all the partitions. I can't just look at one to find that. So it's going to look at each partition in serial and say, is 300 in this index? No. Go to the next partition. Is 300 in this index? No. Go to the next one until it finds it. And it's still going to be fairly fast, okay? But how you make it faster is you add the date to the where clause. And then you notice what it's going to go to. It says, I know what partition that date is in. And boom, it can be much faster in finding that one thing. So the point I want to make here is anytime you partition with a date, putting the date in the where clause really helps performance. And having the date in just a regular date format really helps. Don't do any fancy functions with it or anything like that. This makes a difference. Now, let's take a look at the same thing with PDQ. And I just want to point out one quick thing. I'm going to uncomment out. I'm just going to set PDQ priority to 1 and run it again. And now let's go look at SQ explain. Whoa. So the first set are going to be let's start from the bottom of the file this time, work back. Okay. Now you notice the key word here that I want to point out is parallel. This tells me that it's reading the partitions in parallel at the same time. And it did that for all of these. Just by setting PDQ priority to 1, all of my queries now are being read in parallel. And even if it only needs one partition, that's good. But here, when I read all of the partitions in parallel, it's going to be quite a bit faster. Now, I'm running out of time here, so let me just jump ahead. This is the key thing. When you run set explain, you want to look at, you're either going to see serial or parallel, depending on whether you have PDQ on or off, and you're going to see all fragments or a number of the fragment. And if you see this, it means it's able to eliminate the additional fragments. If you don't see that, it's having to read all fragments, and that and it's usually fairly easy. Tweak your query a bit and get it down to something that works. So I just went through all these. And this is a rolling windows. I've done that. Now, actually, I haven't done rolling windows. So let's do rolling windows. Okay, exact same thing as before, except I've added this one line here. And I'm saying rolling 4 fragments detach. And what that means is only keep 4 partitions. So I have 14 partitions of data here. I only want to see 4. Detach anything more than those 4, and it will do it based on the oldest date automatically, right? So I run the script, but wait a minute, I have 19 partitions and 18 data partitions. What happened? What happens is that detach only happens when the scheduler runs at night. And I want to show you a slide here for it. I know the slide is kind of hard to see. There's a scheduler job called purge tables. And on my system, the default is, at 12:45 at night, it runs. And any tables that have more partitions than that rolling window limit, at this point, it's going to either drop them or detach them. And so don't be surprised. That's why it didn't do it right now, but it will do it tonight. And just as an example, I ran this a couple of days ago, and I have another database here called Partitions 2. And if I go in and look at this database and go into query language, go into info, you can see it detached all of those and created. And since I said detach, it creates a separate table for each one. So I've got a table here called rolling 08, uses a partition name, boom, and that creates it like that. Now, let me go back to my database. So if we kept this webcast going till tomorrow, you would see that. But if you don't want to wait, let me show you how it does it behind the scenes. And what I'm going to describe now is undocumented. So use this at your own risk. But behind the scenes, the scheduler calls a function called db purge tables. And I'm in the right database. Let's go purge function. Okay, here it is. And you notice there's a new thing called exec task in the sysadmin database. This is undocumented. And I'm telling it to run db purge tables on the test partition database. And what it's going to do is go out there and let's see what it did. Now, if I run my show partitions, it's dropped all but the 4 basic partitions. I've got the overhead partitions because I told it that's all I wanted there. And so it's dropped the other partitions. And if I go out there and look, do an info, I've got my tables out there. So that's what's so cool. That took no work. And now I have got a table that automatically detaches or drops. You can do it either way. I did detach, which creates the separate tables, but you can also do drop. And I'm just pointing out this is how in the current version it works behind the scenes. It's not documented, so use at your own risk. If what I do on most real life sites is I wait and let it run in the scheduler. If you have turned off the scheduler, it will not work. And this is a big, the scheduler is becoming more and more important to everything we do in Informix. I know at one point in time I used to say turn off the scheduler, but that was many, many years ago. It's super important nowadays. Now, if you want to write your own script to purge partitions, what you need to do, I want to do one quick thing, 07. The example I gave earlier was a date. This is a serial field partition. And so here I have, I'm going to call this order serial. I want to partition on the order number. And this is actually a good idea for something that you have a serial field. And that's always going to grow. And every time you reach so many serial records, you want a new partition. So what I'm doing is telling it, okay, I'm going to partition by range on order number. I want 1,000 records per partition, and I want to keep 100 fragments. So once I get over 100 fragments, start dropping the old ones, and put them in these 4 databases round robin. I'm going to run that. It says, whoops, 6 data partitions. We expected 4 or 5, 5 because I had rolling windows, and I've got my index ones too. Let's take a look at the show partitions for that. And I've got my overhead table partitions here, and they're my values. So the exact same thing I did earlier, but instead of a date, I'm doing it on a serial number. And this can be very handy if you want to do it on a number. It doesn't have to be a serial number. It could be an integer of some kind that you have. Okay. Last thing, manually creating a script. And this is a script here that reads the sys fragments table and figures out what partitions I want to drop. And then creates a script here that will drop them. And so because the fragment expression is a text field, you can't do matches on it. You can't do wildcard searches on it. And so what I do is I unload the fields I want into a temp table. And there are a number of ways of doing this, but all I'm really trying to do is convert that fragment expression into something I can do a matches on. And then I load that into that temp table. And then I create a script that says unload to detach partition.sql. I'm making the delimiter a semicolon, and I give it the syntax to alter the fragments. And it's going to go out there and alter the fragments where the expression matches. And I'm going to do this on the orders interval table. So after I'm done with this, all the partitions for 2017 will be gone from the orders interval table. So let's run this. I run it. It says 12 rows unloaded. But what it did was it created this script called detach partition, which alters those tables and detaches those rows. And now, if I go back I should and run show partition on the orders interval table. I've only got 6, my 4 plus the 2 for this year. So that basically, this is a SQL script to automate it. And I worked with a couple of companies that, once a year want to detach all their partitions. This is how we can automate that. And if you don't want to use the rolling window option. Okay, I've taken a long time here. I apologize for going over. And any questions? And I'm going to look in the chat. Someone asked, can you create partitions for existing tables? Yes. What you do is you have to look at the alter table command. And it's altering the table. You can init it. There's several options: init, add, drop partitions, and you can do that. And somebody else said with Oracle they had the same problem with indexes that I pointed out, and this is a tip. I don't know if this tip will work with Oracle, but it's what I've found works really well with Informix. Now, I'm way out of time, so if you have any questions, please send me an email. I'll be happy to answer. I want to point out a couple of things. We have 2 new webcasts coming up. The next one is by Art Kegel, and it's called Uninterruptible Informix Transactions. And that's going to be really cool. And then the next one in August is going to be Jack Parker. Jack has been working with us on a 40 terabyte data base migration from AIX to Linux. And we sort of like worked with him and said, hey, we ought to put everything you know about loading and unloading data to move it around into an Informix best practices on that. And so he's going to do that in August. I don't have a registration link for Jack's yet on the website. It will be up there shortly. I do want to point out that we have one more training class coming up in September. There's still, I think, about 3 or 4 places left. The last 2 classes filled up, and this is our new training room. The way we're set up is we can do 8. We have 8 servers, so we can do 8 people, 4 of them here and 4 online, or we can do all 8 online, whichever works better. I don't like big classes. I like to be able to spend time with people. So once we hit 8 students, the class is full. And once we hit 4 on site, the class is full on site, but we can still take 4 people online. And being online is like being on this WebEx, except you get an SSH ID that you can use to SSH into one of our training servers, like the one I'm on right now. And during the class, there'll be a bunch of exercises like this. You get to do them on your own server. And the servers are up and running for the week of the class, and you can work with it all week. I want to mention one other thing before I forget it. Next Wednesday, if you're from Colorado, there's going to be a Colorado Informix user group meeting at the IBM Tech Center. Please, if you're interested, Mike Walker, just Mike at Advanced Data Tools is a contact. I couldn't find a web page with a link for this. I was trying to do that earlier. But if you're from Colorado and want to go, I probably will be out there next week. It's kind of exciting. Let me. Did I had the agenda someplace? Oh, here. This is the agenda. Going to have Stuart out there talking about the HCL and the future direction of Informix. We're going to have an Informix roadmap out there, and then new features and a roundtable. So this is going to be a lot of fun with a lot of good people out there. And that's pretty much it. I appreciate everybody who's hung in on the webcast. Next month we'll have one by Art, so I hope you can join us again then. And thank you guys for attending, and we'll see you next month. And have a good day.